Hello, hello. Welcome to Speakeasy JS. I'm glad that you're here with us today. So Speakeasy is the meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this morning. For those who aren't used to my spiel, I'll just give you a quick intro to what mad science is. It's all about building things that make people say, I didn't know that was possible. And today I'm super excited to be joined by Arjun Barrett, who is going to be talking to us today about his open source project, fflate. Let me just bring him in here. Hey, Arjun, how's it going?
Good. How about you?
Not bad. I'm super glad that you're here. So I'll just give people a quick intro to you. So Arjun is the author of fflate, which is short for fastflate. And it's a library that does streaming, zip compression and decompression. Tell me if I'm explaining that wrong, but it's a super useful library that I'm actually using in Wormhole, which is the end-to-end encrypted file sending service I've been building. And it was sort of the obvious choice for a library that does exactly that that we needed for Wormhole. And I looked at it, and it was just clearly better than all the alternatives. And so we used it, and I thought I would reach out to you and ask you to give a talk. And I was surprised to learn that you're actually still in high school, so you actually had to ask your parents for permission to be on this stream today. So thanks to them for agreeing to let you join us today. And I'm super excited that someone who your age writing code that is already used in real applications in industry, not just Wormhole, but all kinds of different people are using it. 3JS, JS PDF, Mozilla is using it in some of their projects, Sheet.js, and a whole bunch more projects are using it. And I don't think they know that that you're just in high school. So maybe they will now. But yeah. So anyway, welcome. Glad you're here.
Yeah. Thank you so much. So I guess I can kind of start the presentation.
Yeah. Here, I'll put up your slides.
Sure. So I guess I'll just be talking in brief about fflate, which is a pure JavaScript decompression and compression library, which only uses 8 kilobytes of minified JavaScript for its core. So first, I'll just kind of describe what is fflate, and it's effectively a general purpose data compressor and decompressor that works in all JS environments. And I'm trying to, when I say all JS environments, I mean the code is ES3 with some ES5 features, so it works in even IE11 and some weird environments like QML, which is actually a markup language for Qt, the graphics library. Anyway, it implements 3 specific algorithms: deflate, gzip, and zlib, where zlib and gzip are basically just wrappers for deflate, which is the actual compression algorithm. And it does this in pure JavaScript without hooking into WebAssembly or anything like that, while still being faster than WebAssembly implementation, which I'll get to later. So it actually serves a similar purpose to the Zlib library, which is a C library for data compression in these 3 formats. This is not the same as the Zlib format. It's kind of hard to get them to not confuse them, because the Zlib format is a wrapper for deflate, while the Zlib library is a C library for handling zlib data, or gzip or deflate. So kind of confusing, but effectively, fflate serves the same purpose as the C library, and zlib became very popular because it's necessary in all sorts of environments and for all sorts of use cases. Even stuff like PNGs and PDFs use zlib all the time. So if you want to even open those files, it's going to be using zlib somewhere. And what fflate does differently from zlib is that it adds support for zip archives, which I believe were being used in Wormhole. And the reason these are different from standard archives is that it uses deflate on almost every file. I mean, there are some zip archives that won't use deflate or will use some other compression algorithm. But if you take basically any zip file you'll find from the general world, you'll find that it uses deflate or no compression at all. So we can kind of discuss why data compression is useful in the first place, especially in a browser environment. So the obvious answer is that having less data means it's easier to transfer over the network, and it requires less space or less memory. Basically, having less of something like data in memory is always better because it's just easier to manage. And you'll see that compressed data is everywhere. Even in common file formats like MP4s and MP3s, they're going to be using compression somewhere, because if they didn't, they would be absolutely huge. If you take a look at something like a BMP file, which is uncompressed most of the time, you'll see that's almost always multiple times bigger than a PNG, which uses some special compression algorithm along with Zlib to achieve the best ratio. And that's how the majority of these kind of media formats are compressed. However, any other format that can't use some sort of specialized compression algorithm that's more effective than deflate, those will almost always use deflate or some other general purpose data compression algorithm. Stuff like Excel files, PowerPoints, PDFs, PNGs. I mean, there's basically a whole slew of formats that you'll find that use kind of Zlib and the compression algorithms associated with it all over the world. So now I'll talk about why exactly we need this in pure JavaScript. So we obviously want to decode and encode some of the formats I mentioned. Being able to create a zip archive in the browser is extremely useful, because in the past, people would to solve this kind of problem if they needed to create a zip, for example, of someone's personal data to give to them. They would probably host it on the server, compress it on a server, and then serve it down to the client. And this is kind of an issue sometimes, because it's obviously taking server resources that don't need to be used. So instead, we have this library that's able to do the same thing within the browser, and instead you can just serve the raw files that you want to include in the zip archive, and you'll be able to create it on the fly. It can also be used to reduce bandwidth usage when you're uploading data from the browser. So the browser actually supports natively decoding data that's compressed with either gzip or deflate, and that's why you'll often see people talk about min-zipped or minified plus gzipped size of or bundle size of a JavaScript library, or basically an entire code base, because what that means is what's the ultimate bandwidth that's going to be necessary to actually send your website to the user. And it's important that we have gzip data directly in the browser, because otherwise it would kind of be really slow to access any site. However, if you want to do compression on the fly, or decompression from data that's only in JavaScript and not from a server, you have to do it programmatically. There's no standardized compression API. There's one that works only in Chromium right now, but as it turns out, it's generally slower than fflate anyway, which I'm going to do later. But effectively, if you want to an algorithm or a library that does compression in basically all browsers, you're going to need to use something like fflate or one of its alternatives. So now I'm going to discuss why fflate was developed in the first place, why it's necessary versus all the other implementations that already exist. So if you look at the existing libraries, you may have heard of some of these, like JSZip and Paco are particularly popular because they have millions of monthly downloads effectively, but they actually turn out to be slower and larger than fflate for almost all use cases. So for one thing, fflate was actually optimized by hand. It's written in TypeScript, but it uses a bunch of kind of interesting JavaScript quirks, that's how I'll put it, and some minor algorithmic improvements that are able to maximize performance while reducing the bundle size. Like, for example, you can actually add a Boolean to a number, and or subtract a Boolean from a number, and it'll effectively just treat it as a 0 or a 1 automatically without having to cast. And this kind of trick is really hacky, but as it turns out, it's actually pretty easy to optimize for the JIT compiler, specifically V8, which was the main target for fflate, high performance on Chrome and Chromium-based browsers. And it is still compatible with ES5 and all the ancient browsers like Internet Explorer 11 if you want. But the main target is the modern browsers that have support for, high performance JIT compilation. So in general, fflate can be 50 to 200% faster than the other libraries, specifically JSZip, and it's 2 to 10 times smaller, not mainly due to the actual size of the algorithm, but also due to the fact that it supports ES modules completely, while all of these other libraries were built in the past and when ES modules weren't really a thing, so you can't use tree shaking or dead code elimination, whatever you want to call it. And as a result, if you want to use any of the features of those libraries, you have to include the entire thing. And another possible implementation for the same algorithm would be Zlib compiled to WebAssembly. A Zlib compiled to WebAssembly, which is usually slower and almost always larger than fflate, which is really interesting because most of the time people will turn to WebAssembly if they want higher performance for something like number crunching, and that's necessary for data compression. But in this case, the actual cost of crossing the bridge from JavaScript to WebAssembly is actually makes WebAssembly slower, and as a result, it turns out that in this case JavaScript is actually faster than WebAssembly, which is really rare when you're doing something like hard number crunching. The specific number for how much faster it is, I don't remember off the top of my head, but one of the faster implementations I could find was generally 20 to 30% slower than fflate when I tested it in Chrome and in Dino. All right, so what about native bindings to Zlib? When they're available, they're almost always faster than fflate because having a native binding to a C library is almost always going to be faster than JavaScript. That's just because C compiled is usually faster than JIT compiled JavaScript. Even though runtime information is available in a JIT compiler, the fflate was written in a very imperative way so that it can have a faster cold start than some of the other libraries that are available in JavaScript. So in this case, Zlib is almost always faster because the JIT compilation doesn't help much for JavaScript. Just having something that's already fast and is already in the native format for the CPU is just much faster than this JavaScript implementation. And that's why usually it's faster. But in the case of the compression stream API, which was recently announced and is already available in Chrome and Edge, I believe, and some other Chromium browsers, it is actually sometimes slower, or actually usually slower for the average case, when you're compressing or decompressing files that are smaller than 10 megabytes due to the cost of sending the data back into the native, sending the data to the native bindings and coming back into JavaScript. So that means in general, fflate is the fastest available Zlib implementation in the browser, Dino, and any JavaScript environment that doesn't have access to native bindings. So now comes the neat tricks. And this is probably the most fun part of fflate, which is kind of how I made it so small, and also some neat tricks that I just found really interesting that I was able to implement. So this isn't really so neat as it is kind of horrifying, but if you access an array, or in this case a typed array, with an out-of-bounds index, it will yield undefined, and that becomes 0 when you use it with bitwise operations. And this is kind of maybe obvious to some more experienced developers, but what this avoids is the need for a bit buffer, which is usually used in these libraries to avoid exactly this, accessing an index out of bounds, and also reducing the amount of times you access any given index. However, in the case of JavaScript, we avoid the need for a bit buffer, which actually reduces bundle size dramatically. Most of the Zlib implementations you'll see use a system where effectively just keeps iterating through a massive switch case. It has an internal state with a ton of properties, and it just kind of switch cases through all of the possible states and eventually finds which one it's in. Like, is it decompressing the header? Is it finding the LZ lengths, or is it finding the literals? Effectively, when you use a bit buffer, we're able to do this all in a single iteration, which avoids a lot of bundle size. Not necessarily performance, but it reduces bundle size dramatically. Also, something that I found possibly the most interesting part of what I found during development of fflate was the use of inline worker threads that can basically turn synchronous functions into off-the-thread calculations without duplicating code. So usually you'll find that worker threads, if you just implement them normally, are actually really difficult to support in multiple environments. Specifically, the most popular ones are bundlers, Node.js, and just directly in a browser, due to their dependency upon a specific path. This is also something common with something like a dynamic import, where not all the bundlers and Node.js sometimes doesn't support it, so it won't work in all environments if you use it in a library. And as a result, workers and dynamic imports aren't actually often used in JavaScript libraries because half the time they won't actually function. However, the way to avoid this for a worker is to create an inline worker, which effectively just encodes the JavaScript as a string within JavaScript, and then creates a virtual URL using a blob, using URL create object URL. Basically, that just creates a blob URL, converting whatever data you have into a URL you can fetch. And then we put this URL into the worker constructor so that it can access it. And as it turns out, using this technique works in browsers and Deno, while something called the eval option for Node.js lets this work in, well, Node.js environments. The interesting thing about how fflate does it is that it actually dynamically generates the JavaScript string at runtime from the actual objects that are used in the code. So, for example, the deflate sync function is one of the functions used in fflate, and it's actually used to create the string that represents it at runtime. It's kind of hard to explain, but effectively, instead of embedding the code base as a string and then putting that in my JavaScript, then sending it off, which would actually double the bundle size because now you're replicating the exact same thing as deflate sync, but you're also having it in a string. Now we're actually able to avoid that entirely just by using function.toString plus a bunch of other neat tricks that let it become valid JavaScript in the end. And actually, I was able to create this kind of recursive JavaScript value to string serializer, and it's also available on GitHub and on NPM called ISO worker. It basically is an all environments worker implementation that lets you turn any synchronous function into asynchronous without having to deal with any of the annoying bits of actually making that work. So I just thought that was really cool. You can take a look at ISO worker if you're more interested. It's a really interesting concept that I don't think anyone else has done before. So I think that's about it for my brief talk on fflate. So if there are any questions, I'd be happy to answer them.
Sorry, I'm muted. Thanks for the talk. So if you have questions for Arjun, please post them in the chat and I'll ask him. But I'll start with some of my questions. I think the most obvious one is just, I'm curious how you got started in open source. Is this your first project, and sort of, yeah, how did you decide to work on it?
Well, my experience in open source has kind of been a long time coming. I started doing like programming in general just for my own projects when I was, I don't know, maybe like 10 years old, 9 years old, just because I wanted to try out some cool Python scripts I could show to my friends. And eventually that turned into me learning more about JavaScript because I wanted to build a website. And from there, I created my first major open source project, which was a plugin for the parcel bundler that automatically generates a manifest for progressive web apps. And that was my first major project. I was really proud of it. It got like 10,000 downloads or something. And effectively, I was able to create a plugin that I use in almost all of my projects. So I didn't have to deal with like all the annoying bits of actually creating a progressive web app. It just does it automatically for you. And then from there, I was interested in creating more open source software. And from there, I just started putting every project I ever worked on publicly on GitHub. And that's when I created fflate. And when I found out that, wow, this is actually, better than all the other implementations, I just started working on it more, and it became popular.
Mm-hmm. Yeah, and that's really cool. So we have a question here in the chat. what prompted the creation of fflate? So I guess like specifically, like how did you decide that I maybe you just said it, but I missed it. What exactly like about compression was interesting to you, and like yeah, like why did you build something from scratch when there were already libraries that could do it?
All right. So this is actually a kind of funny story. I was trying to create an API for a video game that doesn't have an open API. Basically, I was in a community, I was in some Discord community that was trying to figure out the internals of a popular video game and create an API for it. I was one of the people working on a JavaScript implementation, and when I was trying to do that, we found that all of the level data was compressed with gzip. And I wanted to create this library such that it would work both in Node.js and the browser. So when I found out that the only way to decompress gzip data in the browser, if you had it only in JavaScript, which was the case this time, it was actually within base 64 first. So we had two steps, so it couldn't be decompressed natively by the browser. So to basically handle that data, we had to either create a new library or use an existing one. And as it turns out, when I used all of the existing implementations, the most obvious one was Paco. It like quintupled my bundle size or something. I was just not happy with it. I've always been like super like hell-bent on getting bundle size to like absolutely tiny. So I was like, I'm just gonna learn this algorithm myself and create an implementation from scratch. And I found something called UZIP, which was another interesting library that is pretty fast, much better than Paco, but it had a lot of issues. Like it was not really easy to use, and it didn't offer a nice clean API or asynchronous options. So from there, I just decided to develop it myself, and I tried as hard as I could to optimize performance because I didn't want to leave performance on the table. So I was also just like maximum performance and minimum bundle size. So once I got what I wanted, I just started promoting it and like on Reddit or something. And from there, it just became popular. And yeah, that's kind of how it started, and that's how it went.
What was the game?
It's called Geometry Dash. It's a very popular game for people my age.
Nice. Yeah, I haven't heard of that one. But I totally empathize with finding a library, thinking, okay, this has a good API, but the bundle is huge. And then finding another one that has a good bundle size, but like has a bad API and like is missing a bunch of things that you want it to do. And then just being like, okay, fine, I'll make my own. It's funny because it sounds like it was a little bit of a tangent because if you were just trying to make this API for this game, you could have just just done it and not been as much of a perfectionist about needing the bundle size to be super small. But it sounds like this was like a productive rabbit hole because it led to you like getting involved in open source and discovering this whole world.
Yeah, for sure. I would say that it's definitely a great way to describe it.
Mm-hmm. So what do you like about open source? I mean, do you plan to continue like writing more libraries and continuing to be like involved in the open source community?
Yeah, absolutely. I found that open source is really welcoming, and it's been really helpful to be able to, because basically I've made a lot of projects on my own. Like obviously fflate wasn't the first JavaScript project I worked on. I've done a lot of web apps, just not open sourced, for both myself, for some science fairs, for some local organizations, and in all of them I've just used open source libraries all over the place. And when I compare the amount of code I've written to the amount of code that other people have written for me, I just see that there's so much work that's gone into creating everything that I do from other people. And so I just thought I need to be a part of this. I need to actually help support the community that's helped me so much. So for sure, I'm definitely going to continue with open source. I've released a lot of open source projects after fflate's development. You can probably see my GitHub and you'll check that out. And yeah. That's
super cool. Yeah. You're lucky that you're growing up at a time when open source is thriving to the degree that it is. Like we were talking a little bit in the pre call before the stream about this, but like SourceForge, was like the thing that everyone used when I was in high school, and it didn't really offer the right kind of tools for, it didn't feel welcoming. It didn't feel like a thing you could actually use. And so at the time for me, open source felt like this sort of almost like black magic, like this hidden dark art. Like, who are these people that make all the software that I use, and how, and it didn't even seem like there was a path to like becoming as good as those people. It just seemed like this other thing, like there's some people out there that do open source and then they create these things out of using some magic, and then they put it out there and then we just all use it. And it was like a separation between, the users and the creators, that I don't think there is as much these days, because you can just go to GitHub and see, like, you just click a button and then it shows you the source in a much more easy way than SourceForge, I think, ever did. So you can browse around and just be like, oh, this isn't that hard. I can look at this file and I can just try to read it. And if I see a bug, I can like, click a button and like report an issue, and everything just, it's just so much more visible how stuff works. That's really cool. Anyway, I'm a little jealous of you. But it's cool. So one other question is from the chat is, did you ever end up finishing the third-party API for Geometry Dash?
Yeah, I did actually, and I did actually implement fflate into it. So I think it's called gd.js. It's basically just an implementation of most of the API, and it actually finally supports level decompression, so you can actually access all the level data. And it's funny, I actually just, once fflate became popular, I kind of dropped work on that project until someone on the Discord channel said, hey, are you going to finish that? And I was like, oh yeah, about that. And I just like quickly added it in, and yeah, my bundle size for that was only increased by like a couple percent because of fflate, which I was much more happy about than, completely like blowing it up due to something else.
Mm-hmm. Yeah. Now this sounds like a very productive rabbit hole to go down. The bundle size thing ended up, leading to this useful library that now everyone can use. Yeah, and it is just shocking to me how much like smaller it is than the alternatives, and like, even like when you compare it to compression stream, which is the new API that Chrome just added, the native API, I was like, for sure that has to be faster than fflate, but apparently not. I mean, it's just actually one question related to that I have is like, why do you think that the native Zlib bindings are faster than fflate, but the compression stream isn't? Because they're both crossing from JavaScript to like native land and then back, right? So why do you think there's a difference between those two cases?
So I could be like completely wrong about this because I haven't explored the internals of Chrome as much as I have, or Chromium as much as I have looked at V8. But I'm thinking that for stuff like Node.js, it's a lot easier to access native bindings because it effectively provides, it's like they worked hard on engineering a safe API, like I think it's called NAPI in C, where you can just go to and from JavaScript without too much cost. And I'm not sure if there's a zero copy option for it, but I think the reason that JavaScript is in Chrome is so much slower that you can like never trust the code being executed. So that could be one thing. And I think maybe the other issue is inherent to the actual streaming API, because unfortunately, it looks like compression stream, or basically the entire WebWG streaming system, requires copying the data in a lot of places, because when you're streaming data to and from some sort of algorithm in this API, I've found that you need to copy the data a lot of times. And when, for example, when I tried it with fflate, just doing like one single chunk of data, like I don't know, 1 megabyte or something, it turns out that putting that through in 65 kilobyte chunks ends up being way slower than just having it compressed in one chunk for fflate. Whereas with compression stream, it's basically the same performance, because I think it just goes in chunks whether or not you want it to. So I think the ultimate cost comes down to the fact that with one, you're kind of implementing the format directly, where when you get in one chunk, you're putting out one chunk, whereas with the other, with compression stream, it kind of converts it to multiple chunks, whether or not you do.
Mm-hmm. Right. Yeah, makes sense. Yeah, I've found it's pretty hard to avoid copies in streams in the streaming APIs when I've used them as well. Although sometimes it's just actually comes down to me accidentally doing an extra copy somewhere in the code that I control. I'm actually not sure, like what the stream itself does in terms of copying, but I would totally believe it if there was extra copying going on. Like when you once you like pass a buffer through to you call into the stream API, I could see it doing a copy to avoid like, that data being like mutated later or something like that. Totally would make sense to me. Cool. And I think like maybe we'll have like one final question from the chat now. Someone's asking, what does the future of fflate look like? Are you continuing to work on it or starting new projects?
Well, I think those two options aren't mutually exclusive. I'm definitely going to continue maintaining fflate as long as there are new bugs to fix or kind of new features that I'm asked to add or that I want to add. So, but I think in the past it was kind of like fflate had a lot of bugs. Like I was consistently getting bug reports. Hey, this data isn't decompressing properly. What's wrong with this error message? And at this point, I think it's reached the point where I'm getting almost no bug reports related to the actual compression. I think it's actually fully implemented the actual original format without any bugs at this point. So I'm thinking that from now on, it'll be more like when I'm only going to be updating it when there's a feature request or a bug, whereas in the past, I would just update it on a whim when I thought, hey, there's a potential for performance improvement or there's a bug I didn't catch. And I think I'm going to be starting new projects for sure. I actually recently, due to a question on fflate, they actually wanted to handle data in a format called Z-standard, which is a new compression algorithm created in like 2016, unlike deflate, which was made in 1995, which actually takes more advantage of the resources we have today. Instead of limiting itself to like 32 kilobytes of RAM, which deflate does, instead, this one, Z-standard allows you to take advantage of multiple megabytes or even gigabytes if you have access to that. And as a result, it's multiple times faster and compresses much better. So I created a decompressor for that called FZSTD, very original name. And I put it on GitHub, and I guess you can take a look at that if you'd like. I'm just going to continue releasing open source projects, and I'm definitely going to work on projects in my own time. But yeah, open source is definitely something important to me, and I'll continue to work on it into the future.
Nice. Yeah, you're still at the stage where you are super responsive on GitHub issues. I was actually surprised, like when I think I filed a few issues against fflate, and you responded within minutes, and I was just like, whoa, this maintainer, I didn't, because at the time I still didn't know you were in high school. I was just like, wow, this person's super responsive, and I was really impressed by that. I, on the other hand, have declared issue bankruptcy. I just have so many issues that have piled up that I don't even try to like give anybody the hope that I'm going to look at their issue in a reasonable amount of time. So I don't know. I don't know what I'm trying to say, but just yeah, open source can be overwhelming eventually. Especially, it's not. I'm gonna guess like in a few years you're gonna have enough popular projects that you're gonna be in the same boat, just based on your track record and how good the few packages you've written have already been. So just try to stay sane and don't feel obligated to fix everyone's bugs immediately.
Yeah, for sure. I just I was very, I always wanted to fix bugs as quickly as possible because fflate it's more than just like it's more than just like some project I made on the side for me. It's kind of my only so far project that has actually made it big. So I'm very proud of it, and I want to make sure that it's as good as possible. So yeah.
Mm-hmm. Yeah, totally get it. Yeah. Cool. Well, I think that's all the time we have for questions. Thanks so much for coming to Speakeasy and sharing the story of fflate. I think, yeah, I found it really interesting, and some of the hacks you talked about were super cool. I guess like the toString of the function, and then putting that into the worker with the inline worker URL, that makes sense. I just never thought I never thought of that as an approach to avoid duplication. So that's really a cool trick I'm going to keep in my back pocket for the future if I ever need it. And just thanks for making fflate and for putting it out there in the world for everybody to use.
Yeah, for sure.
Yeah. Oh, one last thing. Someone's asking if you have a link to the presentation. Maybe if you have that, we could share it in the chat. But if not, don't worry.
Yeah, for sure. I could just I have to stop sharing the presentation to do that. So I'm not sure if it's still there. I'm just going to let me just quickly get a link and I'll put it in the chat.
Okay, cool. Yeah, sounds good. And in the meantime, I'll just tell people where they can find your code. It's on GitHub, and I'll put the URL on the screen. Your 101 arrows on GitHub. So feel free to check out Arjun's work there. And okay, I will also put the link to your presentation on the screen. Although it's a giant URL, I don't know if this is actually going to work. If anyone is dedicated enough to type that in to find your presentation, then there it is. Cool. All right, so now